So, good morning, dear student. So, we are actually discussing application of derivative, and there I already discussed the 2 point. One is called rate of change of quantity, rate of change of quantity, and the next one I already discussed, increasing and decreasing function. Increasing and decreasing function. The third one is actually we are going to discuss, that is called tangents and normals. So before going to start this tangents and normals, so first of all you have to know graphically, so what is the meaning of tangent and what is the meaning of normal. Let's see. Suppose this is my Cartesian plane, x, it is y, x dash, y dash. So this is a, suppose curve given, means the function y equal to fx, y equal to fx curve is this one. Now suppose at this point, if I would like to draw the tangent, so this will be the tangent at this point to the curve y equal to fx. Tangent means it will, obviously it is a straight line and it will touch at a single point of the given curve. And then what is normal? So this is called here tangent. Normal equal to, at that point, if I draw a line which is perpendicular to the tangent, that is called normal. So this is actually normal. So wherever you draw the, suppose this is a curve, if I draw the tangent here, this is a tangent. So at this point, if I draw the tangent, this is tangent, so this will be the normal. At that point only, normal is always perpendicular to the tangent. So ultimately, normal and tangent both are straight line, and they are perpendicular, means you got in class 11, when two lines are perpendicular, product of their slope equal to -1. So now, I already discussed in Rolle's theorem, and then how to find the, suppose this is a curve is given, so at this curve if I draw a tangent, then this is called, how to find the slope of this tangent from this curve. So this curve is y equal to fx, so if I find dy dx, that is called, dy dx is called what? Slope of this tangent to the curve y equal to fx. Now see, so if I say slope of tangent is here, so slope of tangent to the curve y equal to fx is dy dx, or you can say f dash x, anything. So now if dy dx is the slope of this tangent, so what will be the slope of the normal? Therefore slope of normal equal to -1 divided by dy dx, because these two are perpendicular, tangents and normal. Therefore you see, if I find their product, this into this, I will get -1, because I know that when two lines are perpendicular, product of their slope is always -1. So therefore, if always slope of the tangent will be dy dx, and the slope of the normal will be -1 divided by dy dx. So this is a very important thing. And then see, two things I already told you. When suppose a line is parallel to x-axis, means suppose this is the curve, if I draw the tangent here, this tangent is suppose parallel to x-axis, then when the line is parallel to x-axis, then inclination theta 0, then actually tan 0 degree, slope is 0. Therefore you can say dy dx equal to, dy by dx equal to 0. dy by dx equal to 0. So it is, as a note you have to write. So when the line is parallel to, if tangent is parallel to x-axis, then slope of tangent dy dx equal to 0, and if tangent is perpendicular to x-axis, perpendicular to x-axis. Perpendicular to x-axis means you can say parallel to y-axis. See, suppose if I draw the tangent here, it is perpendicular to x-axis means here theta 90. So slope will be what? Tan 90 undefined. So therefore dy dx equal to then dy dx. Here slope is dy dx is undefined, infinity. Or you can say if I reciprocate it means dx by dy. So it will be 1 by infinity will be 0. So this is, you have to underline here, this one and this one. When the tangent is parallel to x-axis, slope is 0. When tangent is perpendicular to x-axis, or you can say parallel to y-axis, then dy dx is undefined or dx by dy equal to 0. Now let's see how to find the slope to a given curve at a particular given point. You can see, so that is exercise 6.3. you can see some question. If you solve, then you will get the idea. So first one, it is given, find the slope of tangent to the curve y equal to 3x to the power 4 minus 4x at particular point is given x equal to 4. So it is given, this is my curve. So at this curve, suppose this is my curve. So I don't know the exact, you have to draw it actually. You suppose this is the figure of this y equal to 3x to the power 4 minus 4x. This curve is, suppose this. Then at x equal to 4, suppose x equal to 4 is here. If I draw the tangent, so what is the slope of that tangent? So we already know slope of tangent to this curve is always dy dx. So first of all, you differentiate it with respect to x. So differentiating both sides with respect to x. So this side it will be dy dx. It is 3 constant, ddx of x to the power 4, 4x cube, ddx of 4x is 4. That is 12x cube minus 4. Now once it is given at x equal to 4 at this particular point, so you put here dy by dx when x equal to 4. Then at that particular point exactly we will get the slope of tangent. 12 into it is 64 minus 4. So you multiply it, 64 into 12. So 4 to the 8, 12, 4, 16, 6, 1, 6, 7, 68. Minus 4, that is 764. So this is the, you can say, slope of tangent at point x equal to 4 to this curve. So therefore slope of tangent at x equal to 4 is 764. This is the first question's answer. Now you see the second question. That is again same question. It is given, find the slope of tangent to the curve y equal to, this is given, x minus y by x minus 2. Here condition is given x not equal to 2 at x equal to slope to this curve at x equal to 10. Why x not equal to 2? Otherwise this function will become undefined. So again I have to find dy dx. So right, differentiating both sides with respect to x. So this will be dy dx, and this is this side is suppose dx of x minus 1 by x minus 2. So here you apply u by v form. U by v form means here it is v square x minus 2 whole square v square. Then v first, ddx of, I just write the whole formula, ddx of u minus u, then ddx of again v means x minus 2. So it is x minus 2 whole square, it is x minus 2, ddx of x1 it is 0, so 1, minus x minus 1, ddx of x1 it is 0, so 1. So ultimately it is here x minus 2 whole square, then it is x minus 2 x minus 2, then it is x minus 1, open the bracket, minus x plus 1. So plus x minus x cancel. So ultimately it is minus 2 plus 1 minus 1 by x minus 2 whole square. This is actually this side dy dx. Now it is given at x equal to what? 10. Particular point is given. So now write. So dy by dx when x equal to here 10. So minus 1 by 10 minus 2 whole square. So minus 1 by it is 8 square 64. So this is, you can say, slope of tangent to this curve at the particular point x equal to 10. So now see the question number 3 is same. Find the slope of tangent to this curve at the point whose x coordinate is given to you. You can do it by your own. Find the slope to the tangent. Same question number 4. Now see number 5. 3 and 4 is as it is. Same question like 1 and 2. Now see question number 5, it is given parametric equation. So find the slope of the normal to the curve, slope of normal in this time, x equal to the curve x equal to a cos cube theta, y equal to given a sin cube theta, and it is given at theta equal to pi by 4. So now see, it is saying that find the slope of normal. So slope of normal we know minus 1 divided by dy by dx. This is called slope of normal. So I have to find first dy dx. Then at that point I will put theta equal to pi by 4. So before going to find dx, dy by dx, you see here x equal to it is a cos cube theta. You can write a cos theta whole cube. So this is parametric equation in terms of theta both. So differentiating with respect to theta, dx by d theta, a constant. So d theta of here cos theta whole cube. So here this is cos theta whole cube means you can suppose this is theta cube. So 3 theta square, cos square theta, cos theta whole square is cos square theta. Again d theta of cos theta minus sin theta. That is ultimately minus 3a. This minus is, you can write here, sin theta cos square theta, sin theta into cos square theta. Similarly, y is given a sin cube theta, you can write sin theta whole cube. So therefore again with respect to theta, a constant, it is suppose theta cube. So 3 sin square theta, again d theta of sin theta is cos theta. So ultimately we get here 3a sin square theta cos theta, sin square theta into cos theta. Now we have to find dy by dx first. So now dy dx, how we have found in the parametric equation, dy by dx, you can write here dy by d theta divided by dx by d theta. Now you put the value. So d theta cancel, again I will get dy by dx. So value of dy by d theta is this one, 3a sin square theta cos theta, and dx d theta is this one, minus 3a sin theta cos square theta, sin theta into cos square theta. So 3a cancel. Then you see 1 sin theta cancel, 1 cos cancel. So 1 sin will be in the numerator, minus sign is already there, and 1 cos in the denominator, cos theta, that is minus tan theta. So therefore you can say slope of normal equal to minus 1 by dy dx. So that is minus 1 by, it is dy dx is here, see, minus tan theta, at theta equal to was given pi by 4, see. So put theta equal to pi by 4, so at theta equal to pi by 4, slope of normal equal to 1 by 10, in place of theta pi by 4. The value of 1045 is 1, 1 by 1 equal to 1. This is the answer. Now see, Question number 6 is again same, you can do by your own. Now see question number 7, that is again important question. So question number 7 is asking that find points at which the tangent to the curve y equal to x cube minus 3x square then minus 9x plus 7. We have, suppose if I draw the curve like this is suppose curve of this equation. So not exactly this curve. I suppose this is the curve of this function. Now they are asking at which point to this curve I have to draw the tangent so that the tangent is parallel to x-axis. So suppose at this point if I draw the tangent it is parallel to x-axis. So here I have to find this point. What is x here? Means you have to find that point. Where should I draw the tangent to this curve so that it is parallel to x-axis? You have to find the coordinate actually. So first of all you have to find the slope of tangent, that is differentiating with respect to, you give it number 1, this function. So differentiating with respect to x on both sides. On both sides. So it will be dy dx, ddx of x cube 3x square minus ddx of x square twice x, 2 3s are 6x minus 9. Now it is this is the slope of tangent. So according to question it is saying that the tangent should be parallel to x-axis. So therefore dy dx slope equal to 0. So you have to write according to question dy by dx equal to 0 because the tangent is parallel to x-axis, and I already have written in the starting of the class when the tangent is parallel to x-axis dy dx 0. So dy dx is 3x square minus 6x minus 9 equal to 0. So you can take 3 common here, x square minus 2x minus 3 equal to 0. Take 3 on that side, so x square minus 2x minus 3, 0 by 3 is 0. Now split the middle term, x square minus 3x plus 1x minus 3 equal to 0. So from here x is common, so x minus 3 plus 1 is common, x minus 3 equal to 0. So ultimately it will be x minus 3 then x plus 1 equal to 0. So from here x equal to 3 and x equal to minus 1. So if this is the x, the value of x, now if I put x equal to 3 here, I will get the value of y. So therefore that point's coordinate you have to find. So write putting x equal to 3 in 1, putting x equal to 3 in 1. So it will be y equal to 3 cube, 3 into 3 square minus 9 into 3 plus 7. 27 minus 9 3s are 27 minus plus 27. It is cancel, minus 27 plus 7 minus 20. So if x equal to 3 then y equal to minus 20. This is one point. Again put x equal to minus 1. Putting x equal to minus 1 in 1. Putting x equal to minus 1 in 1. See now this time y equal to minus 1 cube, 3 into minus 1 square minus 9 into minus 1 plus 7. So it is minus 1 cube minus 1, minus 1 square plus 1 into 3 plus 3, minus is there, minus minus plus 9 1 is 9 plus 7. So it is minus 4 plus 16. So ultimately plus 12 plus 12. So therefore the points are, first one is x3 then y is minus 20, or if x equal to minus 1 then y equal to plus 12. So these are some questions I discussed. See, these are very easy questions. So you try to solve. Question number that is I already have given 3, 4 and then 6. 3, 4 and 6. This question you try by your own, and then again next class I will continue. because today you have the exam. So at 9 o'clock, before 5 minutes you try to log in there and then please attend the exam. Thank you.